He might be full up. Let's see what happens. So tell me, I've got 4 people, right? Okay, let me see. This at least one idea is huge. It comes up all the damn time. So if I have 4 people, how many, just if I pick 4 people, how many of them could think this way?
4.
4 could, or?
3.
Or?
No.
0, or?
1.
2, or 1? Okay. All right, no. Do you have to do this work for this problem? No. That's why this is side work. I'm going to get the idea, and then I'm going to show you on the paper the work you would do. So this is the idea. Now there is a probability for each of those, isn't there? Whatever these are, there's a probability for them. Right? Mm-hmm. And if I calculate them and add them up, they're going to equal? 1. So the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4 has to be 1. Let me just stop there. Is everybody cool with that? Mm-hmm. If I add up all the probabilities, it better come out to 1. Now, let me bring in this idea. If I knew the probability it was going to rain today is 2%, what's the probability it's not going to rain? 98%. So the opposite probabilities are always 1 minus 1 is the other one. Is that cool? Okay. Where's at least 1 up here? At least 1 means what? What's at least 1 mean? 1 or?
More.
More. Okay, so here's at least 1 right there. This is at least 1, right? So what's the opposite of at least 1? None. So if I said at least 1 person in here owns a jet ski, how could you show I'm wrong? I might be right. I don't know. Maybe own jet. You would show me that nobody owns a jet ski. That's the only way to show me that I'm wrong. So the opposite of at least 1 is none. And so I know already that the probability of at least 1 should be 1 minus the probability of none because they're opposites. If the opposite probability is a lot easier to calculate, shit, yes, I'm going to calculate that damn thing and then do 1 minus that and answer the actual question, right? You don't even realize how much work would go into this stupid thing. How many ways is there for one person to think that way? The first person or the second person or the third person or the fourth? And what about 2? The first 2 or the last 2 or the middle 2 or the first and third one or the first and holy shit and then 3 and then holy shit. That's a lot of flipping work. But what is that equal to? What is this equal to? It's equal to 1 minus the probability of none. See that? How do I solve for this? I subtract that. Now why does that make... I already knew that. Since none is the opposite of at least 1, that means at least 1 is equal to 1 minus the probability of none. They are opposites of each other. So I cannot always do the probability of at least 1. I can calculate the probability of none and subtract it from 1. Anytime the opposite probability is easier, you can do that and subtract it from 1. Because that's how probabilities work. So what the hell? So now my whole problem becomes, how do I do the probability of none? Okay, so let's come back up here.
93.
So I want none of them to think it's the most important problem. So I want the first guy to not think that. So what probability do I put there?
93.
Yes. He doesn't think so. She doesn't think so. They don't think so either. So do 0.93 to the 4th power, or do all these, and then subtract that from 1. So you just do 1 minus 0.93 to the 4th power. So you get 0.2519. 25% chance, roughly. The biggest mistake there is that people do the problem as if I'm not still talking about 4 people. I am still talking about 4 people, so it has to be some part of it that looks like this, where you have 4 people there. Yes?
You said it was 5 people. Did you just say it's 20%?
If I picked 5 people and the question was the same, it would be 1 minus 0.93 to the 5th. Isn't that kick ass? I mean,
So I don't need to show you all that. Just put 20%.
what? It wouldn't be 20%.
It was 5.
Well, unless you did already. What's 1 minus 0.93? Come on, 0.93 to the 5th. There, 30.4%. Yeah. I lied. Isn't that crazy? Normally what I do on this kind of problem, remember if I did it back here? No. Yes, I did. All right. Normally I ask you probability of none, and then I'll ask you probably at least 1. You just have to know to do 1 minus that. I love you guys. All right, so this last one sounds insane. I suddenly bring into this Brussels sprouts. And you're like, what the shit? So the probability that they think the unifying the country is the most important part. Let me call that the probability of an American thinking that. Let me call it probability of A. So that's 7%. And what am I going to call the probability that like Brussels sprouts? Let me call that P of B. Now, how do I write this then? 4% think that unifying the country is the most important, and think that Brussels sprouts are the best vegetable. So how do I write that in symbols? They think that unifying the country is the most important problem. I call that A. And Brussels sprouts are the best vegetable. So that's that. And then what does that equal to? 4%. And then I ask you, what's the probability? What do I put in symbols for what I ask you? They like Brussels sprouts, so that would be given that they think that unifying the country will not. And what's the formula for this? This is just like the book problems then. Probability of B and A divided by the probability of A. And I know these. B and A is 0.04. Probability of A is 0.07. So what is that, 0.57 or something? 0.5714. So it's all about writing the formula for the question I ask, writing a symbol for all the things you know, and seeing how those work together. Just like the problems in the book. Oh, yeah. So on the back is practice. You do not have to do this if you don't want to. If you get all the homework in chapter 3 done, you should be good. You should be ready. I will have the answer key for this Monday. The double quiz is a week from today. Just on chapter 3. Other than that, I'm done. You guys can head out early. Get your IDs back, please.